Hello, Keith Rucker here at VintageMachinery.org. Guys, over the last couple of months, I have been slowly working on this DoAll bandsaw, trying to get some restoration work done on it. And I apologize, but I really haven't done any videos on it. And here's the reason why, a little backstory on this. If you've been watching my channel a while, you know I picked this machine up. It's been a couple of years ago. It was literally a barn find. I found this in a barn over about an hour from where I live at. It was on a farm. It was under shelter. The barn was open on one end, and this machine had been sitting in that barn, not open to the weather, at least not directly being rained on, but you know, the front was open, etc. Sat out there for years and years and years. And I talked to the guy that I bought it from, and he said he bought it, he was going to put it in his farm shop. It was kind of his farm shop that it was in, where they brought tractors in and worked on them and things like that. And he didn't have three-phase power, so he was going to swap the motor out and just put a single-phase motor in it, and it had been sitting there for 20 years. He decided finally to get rid of it. Now, when I got it, mechanically, I don't think it was in bad shape. It had been running whenever he put it in there. It had a little bit of surface rust on it, but the biggest issue was cosmetically, this thing looked terrible. All the paint was just cracked and peeling, and the machine just looked terrible. So I brought it home, and the reason I haven't done a lot of videos on this is because really the work that has been done to it has just been grunt work, what I call grunt work. And I've had a couple of students that have been helping me. Miles McDonald back during the summer actually got started on this using paint stripper and wire wheels, getting all the old paint off. He got it pretty far along. We got it stripped down, primed. We did a little bit of body work with some Bondo in there, trying to take some dents out and what have you. And then over the last month or so, I've actually hired another part-time worker working after high school. He comes out to here, works a couple of hours in the afternoon. And again, he's been doing a lot of the grunt work around here, the best I can describe it. And I kind of charged him with kind of finishing up where Miles left off. And the main thing that has been done to this bandsaw has just been taking the parts off, cleaning them up, stripping them down, and repainting them and putting them back on. So nothing of really any great significance. It's just time-consuming work. But we've got it along. It's looking great. It's coming along. I've been in the process, you know, and I'll come out here in the evening and piddle for 30, 45 minutes on it or something like that. Put a little bit more back on at a time, and I'm coming along on it pretty good. The only real issue that I had with this saw was, I told you a while ago, they had taken the motor out and was going to put a single-phase motor in. They never did it. They never finished that job. And when I bought it, the three-phase motor had been removed, and they had taken a belt pulley off of that motor, and it was gone. I didn't even really realize that I didn't have it until I started working on it. So let me kind of take you around here to the back, show you what the problem is, and show you what we're going to do to fix it. So I've got you kind of on the back side of the machine, looking down inside of here. This is the gearbox. This pulley here actually turns the bandsaw wheel. It goes through a gearbox, a gear reduction here to reduce the speed. You got the motor down here, and then there's this pulley here. This is an adjustable pulley. It automatically adjusts. There's a handle on the side. When you crank that handle, if you'll notice, it moves that pulley up and down. And the way this works is there's two belts. There's one belt that comes from the motor. It's a wide belt that goes up into this side of this pulley. And then there's just a regular V-belt on this side that goes on the other side. And when you move this thing up and down, it causes the pitch the diameter of this pulley to change. So this thing is spring loaded, where that basically that inside pulley there goes back and forth. So if you raise this up, what's going to happen is it's going to cause the belt on the inside to go deeper down in there, and it's going to at the same time move the centerpiece over. It'll cause the belt on this side to actually move out farther on the diameter, and that's used to change the speed. This is the variable speed mechanism that's in here. The problem I've got is that when I bought the machine, it didn't have the pulley on the motor down here. It was gone. And it's a wide pulley. This belt here is a wide belt. This is just a regular V-belt on this side. And I need that V-belt pulley down there, or a wide pulley. Now, I called DoAll and had a conversation with their parts guy. He was very helpful. Had the parts manual. I actually had downloaded the parts manual off of their website. The problem that I had, and the problem that he had too when he got to looking, was that for this particular range of serial numbers that this machine was made, they didn't have the drawing for that pulley. Now, the next series after the first series, he was able to find the pulley, and we were pretty sure it's the same pulley. I'm not 100% sure, but based on the drawings and based on the dimensions of the parts in here, I think it's the same pulley. Unfortunately, they don't carry that pulley anymore. It's a discontinued part, but they had a drawing, and he was kind enough to send me a drawing of the pulley that we need down here. And like I said, I think that's the only part that's missing on this machine is this drive pulley. So I've got the blueprints. We're gonna get those out, and we're gonna make a new pulley to go on here. Now, the other thing that I don't have is I don't have the belt that goes between these. I know the size belts that go on everywhere else in here, but I don't know the length of the belt. I know the width of the belt. I know it's a cogged variable speed belt, but I don't know the length of that belt. So one ask that I'll have is anybody's got a 26-inch DoAll bandsaw, particularly an early one. This particular saw was made in the early 1940s. If you got one and you can read the part number on that belt, I would greatly appreciate it. Otherwise, I'm going to be ordering a bunch of different belts from McMaster-Carr and just doing trial and error, finding the one that fits, and then have to send the rest of them back. I'd rather have a better starting point than that. But anyway, that's kind of where we're at. We're going to make a belt pulley. Let me show you the blueprint he sent me. So here we go. It's a V-belt pulley, but this is not a standard. Again, it's a wide belt pulley. And I have looked high and far trying to find one that matches this available where I can just go buy one. You know, McMaster-Carr and a lot of the other online supply places, and I just haven't been able to find one, and I've just decided, you know what, guys, this is a fairly easy part to make. Let's just make one. So the outside diameter is about 3 1/4 inches. The width on it's about 1.5 inches. It's just got a V-belt in there, 22-degree included angle on the sides. And it's got all the diameter. It's got everything I need to know to make that pulley. Now, and according to the drawings, the original material was cast iron. And that's what we're going to make it out of. And I get a lot of questions. Why do you make so many parts out of cast iron? Well, a lot of times the reason I make them out of cast iron is because that's what the originals were made out of. And I like to keep my machines as original as possible when I make replacement parts. But in the case of belt pulleys, you'll find a lot of belt pulleys are made out of cast iron. And one of the big reasons is that cast iron will actually grip a belt better than steel will. So I'm sure I could make this out of steel if I wanted to. It'd be just fine. But I've got a chunk of cast iron right here. This is just some DuraBar. DuraBar is a product you can buy. It's actually an extruded cast iron material. This is a little bit large diameter, but I just happen to have this piece right here sitting around. I'm going to have to make it a little bit thinner, reduce the diameter, but I got the stock to make it out of sitting on the shelf. Didn't even have to order any, so that's what we're going to do. And with that, we got our blueprint, we got our material. Let's go over to the metal lathe, and let's see if we can knock this part out. All right, I got my part chucked up over here. And I'm going to start by just facing this. I'm not too worried about run out right now. It's running pretty true. But we got a lot of material to take off, so it will be running nice and true when we get through. This is just a rough saw cut that we're starting out on. Speeding things up a little bit. Pretty much have it true. I'm just putting a nicer finish on this one side. Just skimming a little bit off. Right now my goal is just to get one side trued up on the face. All right. I'm gonna flip my part around and we'll cut it to the proper thickness and get it running true on the other side. I just flipped my part around. We took the lead hammer and kind of tapped it up so that it's running true in the back, and I've got it more or less running true. This is a rough surface on the outside. Engage that back in place there. It's running pretty true on the outside diameter. I'm not worried about that at all right now. I'm just trying to get my thickness to the right thickness, which is I think 1.5 inches. So we're going to go ahead and start facing this off. And we are now faced on both sides, and I can't get my calipers all the way back behind there, but roughly 2 inches right now. So I got a 1/2 inch I got to cut off of this. So I'm not going to sit here and make you guys watch me face a 1/2 inch off, but I'll be back in a minute and hopefully we'll have it down to size. All right, we're getting down. I've been facing this. I've been taking about 100 thousandths per pass and using my power feed on my cross slide and just getting this thing knocked out. Usually when I'm facing, I just do it by hand because I have to reverse my feed rod direction, and it's just aggravating to do that. But when I'm got a lot of facing to do and I want to make some heavy cuts, I use that power feed rather than just doing it by hand. And that's what I'm doing here. Looks like we got about 75 thou. I'm getting a nice finish there. I'm just going to dial in 75 thou and call it good. All right, that should do it. Get our hole going. We'll start with the center there. I just got a center drill in here. We'll get us a nice little dimple in the very middle. I often get asked about how does that thing know where the middle is? Well, the cool thing is when it's spinning, that center bit will, even if it's off just a little bit, it's going to go right to the center, putting that little small hole in there. And now that I got that little dimple to get started on, I can run a drill bit in there and it'll go right down the middle. It's just got to do with the physics of a spinning piece of metal. So now that's going to start right in the middle, and we should have a hole right down the center of that piece of metal. And the truth of the matter is that this is going to be our point of reference when we turn the outside. We got a lot of metal to turn off the outside, so it will be running true to the hole, even if it's off a little bit here, but it should be dead nuts on. First hole was a 3/8 inch diameter just to get me a pilot. I'm gonna slow this down. Now we're going to a 63/64. So this is just under 1 inch in diameter. And final step here is we'll just run a 1 inch reamer down through there, which should take that to the final 1 inch diameter hole and get it right on size. There we go. So we're over at the arbor press now, and we're going to broach a keyway in here again. So 1 inch hole, 1/4 inch keyway. I put in a broach bush in here. There it is. Let it drop down through there, and we'll use a keyway broach. Push down through there. You guys have seen me do this before. Each tooth just progressively cuts a little bit deeper in there, and we'll push it through and let it cut that key through there. All right, first pass. This is a 2-pass operation, so we put a shim on the back side, And we will make another pass, so I'll just take it a little bit deeper and get it to the final size. There we go. And there's our keyway. Ready to go on the next step. All right, getting ready to turn the outside diameter and cut that belt groove in there. And to do that, I've got an arbor here. And it's kind of funny. This is an arbor I made, I don't know, years ago for a specific job that I was working on, where I was doing something like this and needed to turn an outside diameter based on an inner hub. 1-inch shaft. I threw it in a drawer, hadn't used it in years, and now the last 3 consecutive jobs that I've had on a lathe, I've used this same exact arbor because everything's been on a 1-inch shaft, keyed shaft, just like this. So anyway, this is nothing that I bought. I just literally made it out of a piece of scrap metal in the shop, specifically for a job. It is a little bit longer than what I need, so I'm using a bushing here to kind of get out to the end. I just got a bolt that goes up on there, snugs it up. We've got that key to drive it. And of course, we'll come in here with our live center to support it on the end. I've already got this thing running true in the 4-jaw chuck. I didn't show that on video, but I did. Let me now get my wrench. We'll tighten that bolt up, or nut up rather. There we go. And now that is ready to turn the outside diameter, and it will be running true to the hole that we bored in the middle. So that's going to always run true going about doing it this way. Now my outside diameter, let's see where we're at and where we need to go to. The print calls for 3 1/4 inches on the outside diameter, and come in here with a caliper, and we're about 4 1/8 right now. So we've got almost 100 thou, not quite 100 thou, about 90 thou anyway to come off of this. So we're just going to go ahead and start turning it. And when I get down a little bit closer, we'll get some more measurements and figure out where we need to go. Just thought I'd show this again. I've been using it on this project, but I bought this a while back. It's just a little plexiglass shield that is on a little mag base down here, kind of like an indicator. And these things are great. When you're working with cast iron, bronze, some of these materials, it tends to kind of want to just kind of spray a chip back in your face while you're working on the lathe. This right here, you can set it up and it just kind of keeps those chips from coming at you, bounces them back into the lathe, and just makes operating the machine a lot more enjoyable. This is just something I picked up at Char's Tool. This is import. It's a cheap import thing, but guys, for what it is, I don't need anything fancy. This is great, and no endorsements, no kickbacks or anything like that from Char's. Just a satisfied customer with a really neat little product here. All right, we're going to come in here and touch off. And start turning. Another 100 thou. That's we're just gonna take our time on this. That's doing pretty much a full depth cut there. That last one was skipping around a little bit because that outside diameter wasn't running true. Got a total diameter reduction of 150 thou on this cut, so basically making a 75 thousandths actual cut. Just trying to get this thing reduced down in size. I'm going to get some heat in my part, but we'll let it cool down before we finish. All right, I'm down to the 200 thousandths total cut here. This is 100 thousandths off each side. Just playing around, seeing what it'll do. I think I'm gonna get a measurement before we go any further. We're cutting that diameter down in a hurry. All right, so we're about 3 inches 580. We're going to 3 inches 250. So we got, I'm gonna do another 200 thou cut, and then we'll get them in here and start getting it down to size. All right, we're at 380. I'm gonna do 100 thousandths. And then we'll cut into our final diameter there. I'm gonna let that cool down a few minutes, and then we'll get a measurement and finish it up. All right, that should be where we need to be at. Let me get another measurement here. And we're just a shade over 250, so we're right on the money. Change out cutters here. I'm just gonna chamfer these outside edges, break those corners. That looks good. You can kind of see what we're going for here. We got to put this in here. It's a 22 degree included angle, so 11 degrees on each side. Basically taking that down to a 2-inch diameter in the bottom. Now I've got a cutter on here that I'm going to be able to reach down in there and get kind of down in that bottom pretty well. And I'm just going to kind of start on one side. I put some layout fluid and some layout lines on here. It's kind of faint, but I can see where I need to go to in the bottom down there, which is the main thing I'm after right now. And I'm just going to kind of start. I'm just going to kind of come over here. I think what I'm going to do is go ahead and get these lines where I can see them a little bit better. All right. So we're going to kind of come in here and just come across, turn that bottom out. I've got my bottom in here. It's not quite to 2 inches yet, but I'm getting down there close. But before I do anything else down there, I want to try to go ahead and start defining these shoulders. And to do that, I know that according to my drawing, the included angle in there is 22 degrees. So I need to cut half of that on each side, so 11 degrees on each side. What I've got is I got my compound rolled over to 11 degrees where I can go basically just start working that edge down in there and start working that down to get that shoulder form with the proper angle on it. So we'll just kind of come in here and start rolling down through there. Actually, because of the angle, I need to work in the bottom first. And basically I want my edge to come out about where that line is on the side there. So I got a good bit to kind of massage out of there, but I'm getting that angle formed like I want it. So just a little closer look here. I'm just kind of going down to the bottom. I'm feeding toward the back, toward the chuck, and now I'm just pulling it out using the compound by hand and letting it cut that angle coming out. And I'm going to do that all the way back to that line that I've got on the back side because that's the maximum width that we want. We want that to be 11 degrees all the way down to the bottom. So rinse and repeat until I get there, and I'll bring you guys back in a little bit. All right, we're getting really close to our scribed line. I'm just taking a little bit at a time here. Going down to the bottom. The bottom is not the size yet. We'll fix that in a little bit. So I think what I'm going to do here is stop, get my dial calipers. This lip up here is supposed to be 156 thousandths wide. I'm just going to try to get a estimation of where we're at. So we're at about 220. So we got about 55 more thou to go. And I do have a dial indicator set over here on my carriage so I can kind of dial that in. So let me take a couple more passes and we'll bring you back. There, right on the money. All right. All right, I got my compound set to 11 degrees here again. And we're going to start working in that bottom over here. Nibbling it out. Getting down closer there to our scribed mark. I'll start taking some measurements here in a minute to make sure we get it right where it needs to be. But still just facing down this side of the pulley at that 11 degree angle. And again, I'm leaving a little bit in the bottom. I'll clean all that up in a little bit. And the way this pulley works with that belt, it's really more the sides. The bottom really isn't that big of a deal. In fact, the belt probably won't even come in contact with the bottom of the pulley. It'll just be on the sides. I'm just going to kind of go down here and I'm just going to cut across here. Clean that bottom up a little bit. Alright, so I'm just going to go down here until I kind of touch off, barely touch off, about right there. And we'll cut across. should be it. Measure this again with my calipers, get right on the outside edge, and we're within a thou or two of that width, so I think we're good. And with that, I think we got this pulley turned out over here on the lathe. Last step here, I need to drill and tap a hole for a set screw that'll just hold that key on there and fix this to the motor shaft. 1/4-20 is what we're going to be doing, so I've got a number 7 drill bit, which is the drill size for a 1/4-20 tap. I've got it centered up over the key and centered up more or less in there. I'm not worried about getting out edge finders and stuff. I'm just eyeballing this. It's just a set screw that's going to put downward pressure on there. So let's see. Slow that down just a little bit. There we go. And just going to tap it a little bit there to get a hole started since I'm not using the center. And we'll drill this hole on through there. I'll take the drill out. We'll put a tap in here. And just put a little anchor lube on there. Slow that tap down some, and we're just going to power tap this. We'll go down and back up. And there we go. This project is finished. And there you go, one more part all finished up and another part made out here in the shop. I do want to just real quickly give a big thank you to the folks over at DoAll. They don't know that I'm doing this. They did not know who I was when I called them up asking, for this particular part. Honestly, I'm not surprised that they didn't have it in stock. My bandsaw was made in 1940. At some point in time, it just doesn't make sense to keep parts and stuff on these old machines. But what did impress me about them is the parts person there was extremely helpful to me. He took time to go look it up. He found drawings. He sent that to me. Did not charge me a dime for any of that. He could have very easily have just said, you know what, we don't support those old machines anymore. Go figure it out on your own. But no, they stood behind a product that was made in 1940 by at least providing drawings and helping me out. Greatly appreciated. Thumbs up to DoAll, and I greatly appreciate it. And again, that's totally unsolicited, but they, in my mind, they earned some points with me today. And guys, with that, that is going to be a wrap. As always, thanks for watching. Please subscribe to my channel if you haven't already, and those thumbs up and comments are appreciated. Guys, we'll catch you on the next video. Thanks for watching.